So welcome everybody. My name is Jorg. I work for Thread Group, and today I want to tell you something about the Thread wireless networking technology. So Thread is a mesh low power wireless networking technology which is based on the 802.15.4 wireless standard, and 15.4 has been in use for nearly 2 decades by now, for example in Zigbee, so it's a well-known and proven technology. And Thread is an IP-based stack on top of that. Contrary to some other wireless solutions, Thread is not a full stack in the sense that it does not include the application layer. So it's comparable to Wi-Fi. You can run any kind of application that you want to run on the IP network, you can run on top of a Thread wireless network. The Thread wireless stack comprises of IP header compression and transmission control, stuff like that, running on the 15.4 layer, and on top of that comes the applications that you want to use. So Thread is a very important development in the world of commercial buildings, mainly first and foremost because it is based on IPv6. And that means that it can be integrated into existing corporate network backbones. So you can leverage the existing infrastructure that you have based on Wi-Fi or Ethernet, for example. And Thread can be just a transparent extension to that, adding the wireless low power mesh functionality. And since it is based on IP, it uses proven security mechanisms. So the methods that are used in terms of encryption and security that have been used for many IP-based applications can also be used on a Thread network. So it's always at the forefront of new developments in security. New application types and new application domains can always be added at a later point during the development life cycle of a building. So there's no need, typically you have to do a new wiring system and a new network if you want to add a new type of application, say security or lighting or HVAC control, stuff like that. The IP network is transparent to the type of application you want to use. So at any moment during the life cycle of a building, you can add or change the type of applications that you want to run on the network. Thread is a mesh technology. And mesh technology means that the nodes on the network extend each other. So the traffic is going from one device on the network to another device. So there's not one single point that emits the radio waves of the network, like in Wi-Fi, for example. And that means that the more nodes you add to the network, the more devices you have, the stronger the network becomes and performance goes up. And Thread is based on existing technologies. So from the 15.4 radio technology towards the IP technologies, security and routing, transmission control, and the applications, all of those things are basically existing things which Thread brings together into one proposition. So there are several applications that can be used on a Thread network. Like I said, it's not tied to one particular application or one particular application protocol. So you can use whatever you want on a Thread network. And multiple of those applications can be used at the same time on the same network. So even if you have different application protocols for the different application domains that you want to use, they can still leverage the same network and benefit from the benefits that Thread has to offer, like the mesh extending functionality. Those devices even provide that mesh functionality even if the devices are based on different protocols. And many of the well-known and existing building automation systems that are in use today are in the process of transitioning to IPv6 or have already completed that transition. And amongst those are KNX, DALI, BACnet and Matter. Thread is a 2.4 gigahertz radio technology. And that is an important fact because 2.4 gigahertz is the wireless spectrum that is licensed to be used worldwide. So that is important for manufacturers of devices. It means that they can make one device that they can sell all over the world. It makes it very easy for them, contrary to some other frequencies that are different in different regions in the world. 15.4 radios are, like I said, also used in Zigbee, for example, which means that there are already a lot of components and chipsets that you can use if you want to make a thread-based product. And for the development of thread-based products, you can also make use of the open source stack that is available in the OpenThread project. OpenThread is a project that's separate from Thread Group, separate from the organization that defines the standard. It was originally started by Google, and it is a complete stack, so you can use that as a starting point for the development of your projects. So that means that you don't have to start from scratch and can focus on what's really important for your products and what distinguishes them from others. So let's look a bit more into detail in the components that make up a thread network. So this graphic shows the place that a thread network has in the overall corporate building. Most corporate buildings have some sort of a management system, and the devices are connected to that via means of Ethernet, Wi-Fi, familiar technologies like that. And thread is just an extension to that, connected via border router, and I will go into more detail of that later. So the types of devices on a thread network are these types of devices, like the border router. The border router is the function that sits between the existing IP network and the 15.4 thread network. It forms the gateway between those two networks. The leader is one of the devices in the thread network is being assigned the leader role. So that is some sort of an administrational role. The leader device gives each of the devices its function, and if that device for some reason goes offline, another device is automatically being assigned that leader role. So thread is like a self-healing mesh network technology. All mains-powered devices on a thread network are what we call mesh extender devices. So like a light bulb that's connected to electricity to mains power can perform that mesh role. It receives packages and transmits them further to the other devices. And end devices are battery-operated devices, and that's something that's enabled by the fact that thread is based on a low-power technology. And battery-operated devices are in a sleepy mode until they are being waken up by one of the other nodes on the network. And the battery-operated devices can last for many years. So it's a multiple year on one battery, which is of course important in buildings where you might have like hundreds or even thousands of sensors. The border router is like the thing that sits between the thread network and the rest of your network. And a border router is not a bridge or gateway as the concepts we know from other technologies, because it does not need to translate from one format IP to another format. It remains IP. It's just going from the existing network to the wireless 15.4 network. So packages remain encrypted, which eliminates an extra point of security risk because you can remain the encryption throughout the entire part of the IP packages. Thread border router functionality can be embedded into existing devices. So again, contrary to other technologies, it's not a box that you buy that is just a border router. Border router functionality can be in other devices. And in the consumer world, for example, you will see that that will be in a smart speaker or smart display or something like that. But it can also be a light bulb. It can be anything that has the thread radio and some other radio, to perform that bridge functionality. And you can have multiple border routers on the same network, contrary to other technologies, which usually have one bridge. And if that bridge goes down, the network goes down. You can have multiple border routers in a thread network, and if one goes down, the other one automatically takes over that role and functionality. Thread is a low power network. 15.4 has been designed some 2 decades ago from the ground up to perform low power operations. It can have sleeping devices, like I said, the battery operated sleeping devices just wake up when they are needed, and they will remain the packages which are being held by other devices on the network to send them to the sleeping devices when they become available. And the mesh network technology is, of course, very important for the extension of range that you can have in an office building or a factory plant or something like that. The more devices you add to the network, the wider the range becomes. And that is maybe contrary to other devices that might become more unstable the more devices you add to the network. Any mains powered device can be a mesh performing network, and yeah, it builds a strong, more reliable network, reaching all the corners of your building. And if you use specific high power antenna designs, you can even reach further ranges of a network. The applications that can be used with Thread are many. Like Wi-Fi, you can do whatever you want on the Thread network. It's IP-based, it's agnostic to the application, so that I list a couple of them here. It can be anything you can think of which is suitable for a low-power IP-based network. Access control, lighting, safety, your ventilation systems, your air conditioner, whatever. And as Thread Group, we have liaison agreements with a couple of the most important organizations that define the building standards that are being used in buildings today. Like CSA, the organization formerly known as Zigbee Alliance, which is responsible for Matter, for example. KNX, DALI, OCF, BACnet. We are working with all of those organizations. So KNX is currently very much focused on the transition to KNX IoT, their IPv6 based version of the KNX platform. They are going to IPv6 and they are leveraging all the advantages that IPv6 has to offer in terms of security and stuff like that. But it still integrates with existing KNX installations. So if you have a KNX installation with classic RF or cable or even the old KNX net standard, you can still work with all of those classic installations and the new KNX IoT using ETS, the control software that's provided by the KNX Alliance. The KNX Alliance has an open source stack available, for the ease of the development of your products. And at this fair we are also introducing the KNX Point API, which is used in the firmware of the KNX devices. So that eases the development and manufacturing of devices. And Cascoda is the company that's at the other side of this wall, showing the development boards that they have made, that they provide to manufacturers of KNX products, to start up and ease the development. Another popular application that is, transitioning is DALI, the lighting fixture protocol. They are moving to IP and are calling that DALI Plus. They're moving to IPv6, but they remain, fully compatible with the existing DALI. It's just packing the information, the DALI packages, into IPv6 packages. And the DALI Alliance has chosen Thread as their first and foremost and primary wireless application network technology. Going to IP and going to wireless provides numerous advantages, of course. You have all the advantages of IP that I mentioned before. But going wireless for the first time also allows DALI, to make it much more easier to install things. If you don't have to, put wires every time you change, the occupancy of a building, or, you want to go to walls, like glass walls and stuff like that. Wireless applications are sometimes much more easier, much more flexible than wired networks. And lastly, I want to quickly mention Matter, the new standard that defines IoT device types and the properties of IoT device types. And Matter is not a full ecosystem in the sense that a Matter device is being supported by one of the ecosystems that you chose to use. So in the home, that's probably things like Apple HomeKit or Samsung SmartThings or Alexa. And those platforms, those ecosystems, can use Matter devices. And you can even use multiple of those ecosystems at the same time to control the same Matter type of devices. And we will see a similar development in the commercial world. And nothing is preventing the commercial building automation systems that we have today of using Matter as one of the supported device types that they can support. So it will be just one of the types that's available to consumers using those platforms. And then finally, a quick word about Thread Group. So Thread Group is an organization consisting of some 250 companies at this point, Big companies like Amazon and Apple and Google and a number of big building automation companies and silicon vendors are part of the threat group and are participating actively in the numerous working groups that we have developing the parts of the standard. And when you become a member of threat group, you get access to the IP, to all the specifications, all documentations, you know, to build your own products. So threat is very much mature technology and it's ready today. So that is my quick story, a quick introduction to the threat technology. We put a specific website online that lists pointers to the news releases that we recently had about KNX and DALI, and some pointers to resources like white papers and brochures and stuff like that. So I all encourage you to visit the website and have a look for yourself. That was my story. Thank you.